Hi, everyone. I can see we are slowly gaining quorum. Let's just give everyone like 2 more minutes for those who are about to sign up, and then we can get this show started. Hello, can everybody hear me? If you can, just type in the chat box yes, and we can start.
Yes, I can hear you.
Good stuff. So welcome everyone. I would like to thank you all for joining us for today's webinar organized by Vodafone Africa. My name is Charles Kahiro, and I am the Creative Director at RaboWorks Africa, which is a leading provider for consulting services in organizational management, learning, and development. For today, our presentation is on establishing a fair data point. And we have the lovely opportunity of hearing from our presenters led by Luiz Bonino, who is the International Technology Coordinator at the Go Fair International Support and Coordination Office. He is joined by his colleague Case, who is the lead engineer. Luiz and Case, it's great to have you here, and a big thank you for doing this.
Thank you everybody. Let me start sharing my screen.
Before we start, Luiz, just a small overview of the presentation and then a little housekeeping for the sake of flow. So just to give you a small overview of the presentation, Luiz will be taking us through the concept and architecture of a fair data point, as well as he will be covering some of the data models applied therein. And then Kes will then give us a step-by-step walkthrough of the technical aspects of what it takes to get a fair data point up and running locally, and then how we can also take those lessons and apply them to the server side of things. Just a little bit housekeeping before we begin. Let us all have our mics muted during the presentation, mainly to prevent background noises from disrupting the flow of the presentation. So if you have not done so, just take some time to do so now. Also, we would love to hear from you. And as such, if you have any questions during the presentation, we would like you to type them in the chat box of your Zoom control panel, and I will bring them up during the presentation. And we will also have time for questions at the end. If you do have a burning question or something that you need clarified as the presentation goes forth, be sure to use the controls at the bottom of the participant panel to raise your hand, and then we can give you a shout out, and then you can unmute your mic and ask your question, more or less. So without much further ado, let's get the show on the road. So Luiz, the floor is yours.
Okay, thank you. Okay, so let's go forward. As Charles said, my name is Luiz Bonino. I work for Go Fair, but also for the Universal 20 and the Leiden University Medical Center. And Casey and I that we're going to present today, we have been involved in this fair things from the beginning, and for the last almost 6 years already, we have been working on trying to develop some technology to support the fair principles. And Casey has been the lead engineer in this whole process, and is one of the fathers of the baby that we are going to talk about today. Just very shortly to contextualize this, so we are talking about this in the context of the virus outbreak data network, VODAN, and VODAN. The name is used in two different aspects or contexts. One is as a Go Fair implementation network, which is a public-private partnership, as every Go Fair implementation network. And the goal is basically to support, create, develop, demonstrate, and deliver elements for improving aspects, being policy, being training, being technology, different aspects related to the virus outbreak. And the idea is to now, of course, we are focusing on the COVID pandemic, but the idea, that's why VODAN's called VODAN, not CODAN. It's not specifically for this. The whole idea is to lay out a kind of infrastructure or a set of elements from technology, from policies, from practices, and so on, to have the world better prepared for virus outbreaks. This is one that we are going through now, but there will be other ones anyway. And the implementation network is divided in different clusters that now have, I don't know, 10, 12, 15 clusters, from the core specifications of fair elements to computing capacity, authorization, authentication infrastructure, data stewardship, conceptual modeling, training, etc., data entry. So we have all these different aspects, and because the implementation network became, let's say, known very quickly, and a lot of people joining, we already have, going to 200 participants. We thought that would be a better idea to cluster them so we can get people focused on different aspects. The other way of look at VODAN is through some specific projects, and now we are talking about two highly overlapping projects. One is funded by ZonMV, which is a Dutch healthcare funding agency, and another one from Philips Foundation. And both of them, among other things, focus on the technical parts, and that's my responsibility. We are supposed to deliver three main technical elements. One is a semantic data model for a particular type of data set. I'm going to talk a little bit more about this later. Another one is to deploy a number of data points to expose the metadata about any kind of data related to the pandemic now and later to any other virus outbreak in a fair way. And then take all these models and the data points, the installation, the documentation, the recording of these webinars, everything that we need to make it easier for anyone else to deploy and use this infrastructure. We want to pack together, and so we are going to use these webinars to test the content and adjust that, and then have a final version where all the things will be streamlined. So the current situation is that we have the general population, but they also have healthcare providers, we have researchers, we have policymakers, decision makers, governments, and so on. Everybody is in panic mode. and trying to find solutions for their own perspectives. But the major struggle now is, first, what's available, what's out there. It's hard to get to know what's out there, and where can I find things, data or policies or samples or whatever you're focusing on. Everybody has more or less the same difficulties. What is there? Where can I find, and how? What if I get to know where can I find something? How can I know if I can use? What are the conditions? How can I properly reuse this resource or this asset? So the Vaudin approach, we try to look at this in dividing things in three different layers or abstraction perspectives. One is that we have real world phenomena. We have the virus going around. We have the virus interact in everybody's body in a different some ways. We have proteins, we have enzymes, we have genes. We have all these different things, and we have blood samples that we need to have medications. We have the DNA of the virus, of the people. We have all these different type of real world phenomena, and we have data that we use to capture the representation of this phenomenon. And then we have metadata that are used to describe this data that represents the real world phenomena. So this is just to contextualize when we are talking about the semantic data model and the federa point, to have clear that we have these three different things, these things in reality, the data that represents the thing, and the metadata that represents the data, or describes the data. If we go back to these three deliverables, the first one is a semantic data model that's specific for the World Health Organization case record form for COVID-19. So the World Health Organization released this this document. It's in fact, it's a PDF document. This is the link underneath for the original one from WHO. And it's a form, so it starts with some one page with some introductions, but it is a form in the old sense that it's a PDF form with the fields and check boxes and questions, yes or no, and so on. And this form is divided in three different modules. One that should be filled when the person is admitted in a health center to be treated. The second one should be filled in different quantities, so daily or whatever the resources are available to get this frequently filled. There's a kind of follow-up form that you fill, for instance, daily to see what happened with the patient, what are tried of medications, the results of the tests, and so on. And the third model is to be filled when the patient is exiting the health center. In this sense, when it's discharged or dead. This is just a part, the initial two blocks of the form with some data. But the way it is, it can be used in two different ways, or it can be printed and then filled using pen or pencil on paper, and then the machines will have a hard time in making sense with the collected data. Another way that this can be done is filling directly the PDF form, electronic, or using some other type of interface where you can enter the data, a web form that you can answer the questions, entering the data in a more structured way. Regardless, the computer will have, the machine will have some difficulties in understanding what's that about. For instance, if you look at this box, the clinical inclusion criteria, you have one sentence, proven or suspect infection with pathogen of public health interest, yes or no. So the yes or no boxes are just located in the same line of the question. So we can infer that there is a relationship between this yes and no to that question. But then we have the other ones that, for instance, the cough, it's the yes or no of the cough is really far away from the question. It's closer to the history of self-reported feverish or measured fever of more or equal 38 degrees. So this yes or no for the cough answer question is closer to the first question than to the second question. So we have no problem in understanding this because we are used to deal with this kind of forms. But for the machine, this is just at best a bunch of characters and symbols like the checkbox and the boxes themselves spread around in a document. So it's hard for it to make sense. Then to avoid or to make this process easier for the machines, we wanted to define a semantic data model to support the semantic annotation of the data created based on the CRF from the WHO. We have the focus here is on machine actionability by providing semantic references for the forms, questions and answers, what this question is about, and the answers, are they related to some existing concepts in existing vocabularies. So we are not, we didn't aim here to define a conceptual model for the biological phenomena. We are not going to explain in the semantic data model what causes a fever, what's a fever in the sense of it's a result of some biological process and so on. This is not the case. It's just say, whenever there is this question, did you have a fever in the form, we capture the information of this question by referencing a concept about fever that already exists. The model is, of course, open access. We created a persistent identifier because we should follow the FAIR principles, right? So the first one demands us to have a globally unique and persistent identifier. So we created an identifier for the model itself. We published that on BioPortal, and we have also documentation to help anybody that wants to use that. If you access BioPortal, it also provides some facilities, some kind of user-friendly interface for people to get to know the model. So this is just one diagram about the model, a visual representation of a part of the model. So here we have the concept of the WHO COVID-19 rapid CRF, which is a subtype of a clinical research assessment questionnaire that's related. It's about, so whatever CRF, that form that we are filling, the form is about a person, a entity of type person, and the CRF is divided into three different forms: the admission form, the follow-up, and the discharge death form. And if you start, we start drilling down on this conceptualization, we have, for instance, the admission form has sections like a pre-admission and chronic medication, signs and symptoms, demographics, comorbidities, and so on. And then you go further and further until you have also the answers. For instance, here we have a question, which is of type yes, no, or unknown question. That's angiotens in converting enzymes, and so on. And this question is related to, it's about a ACE inhibitor And in the yellow box on the right, you can see some of these properties of this concept in the model. So here, basically, we are creating a between the concept that we defined here, that we are reusing the identifier of a concept defined in the NCIT vocabulary, thesaurus, and we are defining mappings of exact, to say that this concept in NCIT is an exact match to that concept in LNC, and the other one in MASH, the other one in SNOMED-CT, and so on. So in this way, we also, by having these annotations on matching, conceptual matching between the terms that we are using in our model and equivalent terms defined in other vocabularies, we are helping improve interoperability among the data that has been annotated using these different vocabularies. And here's how we connect the model with the form. So here on top you have a excerpt of the form, a section on medication. Is the patient currently receiving any of the following types of medication? And then here, this section is defined here, is about a concept that's called medication. And then we have one specific, as an example, one specific question here, angiotensin converting enzyme inhibitors. And then we capture this question in this concept, which is a question. And we are saying here that this question is about or relates to this concept of ACE inhibitor. Also, another example of a question that we are providing a set of different mappings for concepts that are related in different vocabularies. So for instance, the question antiviral, are you taking, or is the patient taking antiviral, yes or no? And if yes, what are some specific types of antivirals that they are taking? So the concept of antiviral in general, we are informed that it's equivalent to antiviral agents in MASH, to antiviral agent in NCIT, to antiviral in SNOMED-CT. And the same we are doing for the specific instance of antiviral, like ribavirin, lopinavir, and neuraminidase. So this is more or less the idea of the model. So going to the second deliverable that we have, which is deploy a number of feather points. So first, what's a feather point? So feather point is a technology that we have been developing for the last years that provides access to structured and semantically rich metadata that describes different things. So here we are saying that the metadata that's provided in the feather point describes the data source itself, or whatever solution, repository, or whatever application that's providing the data, the groups of data sets, because you can provide the metadata about a set of different things, metadata about the data sets themselves, and the accessible methods for each of the data sets. So how do you represent these data sets? I'm going to go explain this better in the coming slides. It provides a common interface to access the metadata based on the REST APIs. The code has a MIT license, and here I put the link to the GitHub where you have the code base. We also have a specification, because the original idea of the feather point was to provide a set of specifications for what we expect as behaviors from applications that provide metadata in a fair way. So in this sense, you don't need to use our reference implementation. You can just take the specifications and extend whatever application that you already have with the expected behaviors from the feather point, and then your application will do whatever was already supposed to do, plus is going to behave as a Fedora point. And then we also have, if someone wants to use our reference implementation, here we have the documentation about how to install and deploy. And Case is going to go through this documentation and demonstrate how this can be done. So the general architecture is that you have the Fedora point. Let's say it's a server type of application that stores metadata primarily, and of course for its operation it has some other types of data that it stores. For instance, access control, because you can have you can create different users with different rights to provide metadata for you. It's not that you deploy metadata and everybody suddenly is able to insert a new metadata in your Fedora point. So we can control this access, and the information about the data about access control is also stored at the server. Then we have applications that can navigate through this API and interact with the API, for instance, to retrieve the metadata content. And so then you can have a number of different third-party client applications that can interact with the API. And to facilitate the use of the Fedora point once it's installed, we created our own web client. It's just one of the possible clients that can be connected to a Fedora point, but we also have a reference implementation for this web client, and I'm going to show you how this looks like. If you don't want to use our, so this is the basic architecture. If you don't want to use our reference implementation, you can use the specification, and then you have your own application that stores things and has some specific functionality, has some specific API. We don't need to disturb any of this, and then you just extend your application by providing compliance, a kind of layer besides on top of your application, to provide the expected metadata content navigation API from the Fedora point, and to follow the Fedora point's metadata structure. And of course, you can change, and we are in our implementation, we are working on facilities to make the extension of the metadata structure easier. Our reference implementation is divided in this way. We have this Fedora point web client. We have the server. We connect to the server a triple store to store the metadata, and we connect a MongoDB instance to store the access control data. And for instance, for the triple store, you can have a triple store in memory, which is useful if you want to have it in your machine just for demonstration. But every time you restart, things may be gone. The data will be gone, and you have to enter everything again. So it's not very useful. But you can also have the native store based on the Java code. But also you can connect existing triple stores like a Lego Graph, GraphDB, BaseGraph, and so on. And now today, last evening, we released the version 1.4 of the Fedora point. We have also, let's say, more technical interface, web interface. It's common for computer science. It's a Swagger interface where developers can use this interface to more easily interact with the Fedora point's API and tests and so on. So we can test this using this interface, and then once it's working as you want, then you can, for instance, implement in your application whatever interaction that you were testing using Swagger. The Fedora point basically defines, we ship the Fedora point defining this structure of metadata. We have the metadata of the Federa point itself, the metadata of the catalog, and the metadata of the data set, and the metadata of the distribution. And of course, we didn't define ourselves. We didn't want to invent yet another metadata schemas. So for the data repository, we based the specification of the Federa point data repository metadata layer on RE3 data, which is a registry for research data repositories. And they have a schema for a metadata schema for people that wants to register their own repositories there. For the catalog, data set, and distribution, we are using DCAT, and we are currently migrating to the new version of DCAT. This is the web client. For instance, I created a Federa point in I have a Federa point in my machine, and I created this. I populated this with demonstration information, metadata in this case. So this is the page that you can see the metadata of the data repository of the Federa point itself. So I have the title, I have some descriptions, and that this Federa point contains metadata for demonstration purposes. And then when the metadata was issued and modified, the version, license, specifications, because we for each metadata layer that we defined, we have a specification of the schema for that layer. That we use also to validate whenever someone is sending or adding a new metadata to the Federa point. But also we use that to automatically generate the entry form, the web form, to help people create new content. So we have, and here you can already see kind of summary cards of the catalogs that this Federa point have. So, and then you can select one of these catalogs, and then you see the metadata of the catalog. So this catalog contains a number of data sets related to COVID-19 from the Netherlands. So because it's the COVID-19 NL data catalog, and then the version, license, and so on. And again, now we have the kind of summary cards of the data sets inside that catalog. For instance, demo, WHO COVID-19 CRF data set, or genomics data set, or metabolomics data set. And you see, maybe it would be better if I show you. Let's try to do a dangerous thing here. Let me try to show you live my Federa point. I'm going to reshare my screen with the yeah. Now you see my screen again, right?
Yes, we do.
So this is the Federa point I was talking about. So we have all these catalogs. I can just select one of them, or I can edit because I'm at the Federa point level metadata. So I can, I'm logged in. So if someone is just visiting your Federa point, it's not allowed to edit any information. It's just allowed to see the information. But I'm logged in. I have the rights to modify things in this Federa point. So then I can edit here, and I can add some or change some information. For instance, there was a typo here. Then it updates that. And for instance, here, this is representation. This web client, as I showed you in the architecture, this web client interacts directly to the Federa point API. And the Federa point API primarily retrieves information in RDF, in a machine actionable format. So this is the RDF that any other client interact with the the interface with the API directly is going to see all the information that I have in my Fedora point metadata. So, and this is how this web client, which is an application on top of the Fedora point, takes that RDF data and renders in a more human-friendly way.
All right, Luis.
Yeah, go ahead.
If we can just pause a bit. I see we have some questions coming in through the chat box. We have Susan asking, have we got the access control metrics? Have we got the access control metrics for different user roles documented somewhere, or does the metrics vary based on where the fair data point is implemented?
Oh, yeah, no, sure. Here you can, so we can create users here. So I'm admin, I have user, we can create a new users. And for instance, I can see here, that's my metadata that I created. So I created all this, I'm the owner of the metadata, but I can assign, because I'll explain why there is an error, because I assigned a global unique identifier in the configuration. But you can assign different users to, for instance, you can create a catalog that and give authorization to a different user to access that catalog. And then the person can add it to the catalog and can add data sets inside of that catalog.
All right.
Then, yeah, so you can have. By the way, and that's a problem. We have the documentation for the deployment. We don't have yet the usage documentation. So we should produce that as part of that package that I mentioned as the deliverable, the third deliverable.
Yeah, I think that does answer Wondimo's question. He was asking whether we can get a reference book or a manual guide in addition to the slide.
Yeah. Now you can't because it doesn't exist. But we have to produce that.
But it's on the way.
Yes.
Put it that way. There was someone also asking whether the demo site is available online, and just check the chat box. Case has shared the link to the demo deployment so that everybody can access it.
It's the content there is a little bit different from this one, because that's in my machine. I was just creating, as you can see from the dates here. I was this morning creating this content just for this presentation. So then we have the catalog that we go to the list of data sets, and you see here that each data set has this box with some weird code. Let's open this data set. So it has these themes, which are just codes that are being shown here, and we have keywords. This is a feature from DCAT that they define 2 ways that you can create some very loose references between terms that are related to whatever you are presenting. So here, the keyword, as we use keywords commonly, are terms that roughly represent what we are talking about. So this keyword in DCAT, keyword is the human readable version of this idea. So here I have COVID-19 case report form, the Netherlands, World Health Organization, related to this data set, because it's a data set with mocked up data about the WHO, so the World Health Organization, COVID-19 case report form. So that's why I added this these keywords here. But these things don't mean much for machines. And DCAT is a W3C documentation standard that strives for machine actionability. So that's why they have also, besides keywords, that's only for human consumption, they have the idea of theme, that's the same idea of keyword, but for machines. So these are actually references to concepts in different vocabularies that are about this data set. For instance, if I click here, Q55, if you look at maybe it's just too small for you to see at the bottom of the screen, that it points to a entry of an entity at the Wikidata. If I click here, the identifier is resolved, and then I go to the concept of the Netherlands in Wikidata. And again, this is just the human readable way of seeing this information, because it's an HTML page. But if my machine follows this link, it will receive or a JSON or a RDF version of the same content. And the same here, if I click on this one, I have the concept of COVID-19 as defined in the human disease ontology. So this is the way that I can add a reference to, in a machine readable way, of what this data set is about. And then the data set, this is another feature from DCAT. A data set can have different distributions. So for instance, for this test data set that I have here, I have a CSV distribution, I have an RDF distribution, I have an XML distribution. So they are different representations of the same data set. So, and then here, if I click on the XML distribution, then I'm taken to the metadata about the XML distribution of that data set, of my WHO COVID-19 CRF data set. And then here I have the access URL. If I click that, then I'm transported to the actual place where I can download this structure export all file in XML. So then I can, by following all this, and here also in the metadata, it says that the media type that I'm going to provide you once you access this is an XML format. So by navigating through this chain of metadata, you get to know what application you are dealing with, in the case here, the Federal Point, what it has to offer, these different catalogs. For each catalog, what are the data sets that they have, and for the data sets, what are the distributions that they may have. So coming back to these slides. So these already went through. This content here. Any question about this?
Do we have any questions before we move to the technical installation of the FAIR data point? Someone is asking, what is FDP? FDP is FAIR data point.
Yeah. And by the way, I know that there are some people from GoFair Brazil here, and I'm Brazilian as well, although I lived in the Netherlands for a long time. Just an apology, because I gave the name of this. I gave the name of the Federal Point, and I never noticed this. Only the first time that I went to Brazil to present this, that I used the acronym, the FDP, that I noticed that in Portuguese, FDP is the acronym of a very bad word. So,
apologies.
Sorry for everybody.
Well, we live, we learn, isn't it?
Yeah.
There's a question of whether the data point itself can be installed on cross platforms, whether it's Windows, Linux, or Mac. I think that will be a question for Case to answer as he sets up.
Yeah. It's a Docker, right? I have a Mac here installed in my Mac. We have in a Unix as well. So, but if there is no more questions for me, then we can move to Case.
Yeah, I believe so far that is You can take a break now.
Charles, this is Miriam speaking.
Yes, Miriam.
Hi. I just had one question to Luis for clarification, because in the training so far, we have really been emphasizing that the FAIR data point allows the curation of data in residence, and so that the ownership of the data remains distributed and in residence. Perhaps Luis could just clarify how in the context of the FAIR data point that is ensured.
Yeah, sure. Let me just show you how this can be done. Okay, for instance, imagine that I have here, the majority of the people in the call are from Uganda, right?
No, from different countries on the African continent.
Okay, so let me just be neutral and put in the Dutch here. So imagine that I'm using a federal point to expose data here in the Netherlands, and I happen to know that there is a data set in one hospital here, for instance. Then I'm going to create a new data set. Let's say the LUMC, the Leiden University Medical Center, COVID-19 data set. And then I can enter whatever information here, my test data set. Some version, and then you don't need to enter license and language because it adds automatically. The default, if you want to enter a specific one, you can do that. The themes I'm not going to enter now. Okay, so I have a data set now, which is just a metadata of a data set. I don't have the data set itself. I have the metadata, and I'm going to create the distribution. Let's say zip or Excel sheets in a zip file, and then create some description here that people can access, and then we have a download URL. Here I can say that I can put the reference to where this thing is located. For instance, you can say lumc.nl/my/my zip file.zip. And then it's, I don't remember if it's application.zip here. This points to a place that I can download this file, but it's up to who is storing the actual data to determine the access restrictions, right? And I can put the licenses here, or I can add a metadata element of rights or restrictions content, where I can explicitly state what are the restrictions to access that. So here I'm just provided the metadata. The data is stored wherever it's already stored. Of course, you can use, since we already have the triple store attached to the federal point to store the metadata that's published in a federal point, you can use the same triple store to store the data as well and give access to the data. And then if you do that, you have to configure your triple store to whatever access restrictions that you may have. So in this sense, a federal point does not dictate who and how and what needs to be shared. It's up to whoever is hosting and making the data available.
Thank you, Luis. Charles, I know that the clock is ticking, so I'll just talk very briefly with one line. And that is that we have also emphasized in the training so far that it's not about downloading the data in a kind of a new central database, but about the tools, the algorithms, visiting the data. I'm sure that this will be coming back in the metadata for machine workshops that we'll be having from here on. But I just wanted to mention it so that there's no confusion on that point. Thanks, Luis. Excellent presentation. Thank you so much.
Welcome. And about, just one last comment about this data visit. For instance, we could this distribution of the data set, instead of being a file or being a page where you can download stuff, it can it can be a query, a specific predetermined query that will do some processing at the server where the query is running, and we only results returns the results. So this is one of the possible ways of keeping the data where they are and just returning results of analysis. Okay, Case?
Yeah, I see there was one question in the chat. Is there a data limit in terms of capacity for this system? I might as well take that up front. It's fairly lightweight, the for data point, so it's mostly limited by the data storage you have behind it. We deployed it with reasonably sized data sets. There might be some things in the interface where if there's a gazillion data sets displayed, that things might be not as user friendly as we want them to. But capacity should not be a problem, depending on the data storages behind it, of course. Let's see if there are any questions.
Yeah, we have one. How does the data set get to be referenced by the DCAT code that is machine readable? Is it automatically generated on data set creation?
Let's see, how does the data set get to be referenced? So we follow the structure that DCAT prescribes. So we have the catalogs and the data sets and the distributions. So the actual data, so let's say the Excel sheet in Luis's example, will be referenced by the distribution within that DCAT metadata. I'm not 100% sure if that's your that answers your question, but that's my interpretation of your questions. And for the training, I'll leave that up for someone else to answer the training question.
No, it's all right. Maybe we can start, and then we can save most of the questions for.
Let's see. I want to share my screen, but let's see if that actually works. Oh, I need to grant access. I hope that works without things breaking. Let's see.
I see Ondimo is raising his hand.
Hello, Luis.
Hi.
Thank you. Sorry, I lately joined just to ask one question. How we can manage this? Because, you know, for example, if we want to handle a data like multi-source data service and disease type of data, is that possible to manage such type of data using fair data point?
It's all the fair data point is all about metadata, right? So we can have. I didn't, because we released a new version last evening. I had a fresh install today, but in my Fedora point until yesterday, for instance, I had metadata about the data sets, files, and triple stores, data, and so on. You know, typical concept of data set. But I also have metadata about websites. So I had a catalog here with in my Fedora point with with a number of websites that have COVID-19 data, like this dashboard or COVID-19 related information, like this dashboard and things like that. So even we could have a catalog, for instance, even with metadata about hospitals that still have available places for intensive care. So, and of course, it's up to whoever is managing this to keep this up to date and so on. But no, it's all about metadata. The Federal Point does not deal directly with the data.
Okay.
All right. I'll take it from here. I don't have a view on the Zoom control stuff at this point, so I'll ignore any questions. So Charles, feel free to interrupt me if there aren't any questions.
For sure.
That said, I've done this more times than I can count. So if I skip over things or if I'm going too fast, feel free to interrupt, because yeah, it's. I've done this so many times, the deployment stuff, I probably skip over things that I take for granted that might not be as simple as they are. That said, this will be a bit technical, so I guess certain knowledge is assumed. So I'm using Docker as the main platform to deploy stuff. So if you don't know Docker yet, just assume that there are VMs that are controlled automatically and things are easy in deployment and management of that. I'm not sure if it matters, but these are the versions I'm currently running. So if something doesn't work, if you try it, then maybe you have an older version that could be. Just for reference, these are the versions I have. All right. So, given the explanation that Luis just did, now we'll go into a bit more technical walkthrough of what things look like. Well, not necessarily under the hood, but at least I won't go into any architectural things or any abstract discussions on what is metadata and what can be contained. This will be how do I deploy a data point. Someone already pasted this link in the chat. It was in Luis's slides too. This is what I'll be using as the main reference point. This is the documentation that's partially generated automatically, partially written manually to explain, well, things about the data points, specifically the reference implementation. There are some things about the roles, so the questions about the access control stuff. There are some things explained here. Feel free to read that. I won't go into that right now, but there is at least some explanation on that. So what we will be doing is we'll be diving into the deployment section. We'll start with local deployment. I won't go into a full-fledged server deployment right now, but we can at least see what is there and what is needed for that. So for the local deployment, for the very, very basic stuff, this is all you need to get up and running on your local machine. We'll do that right now. We'll just copy it, paste it in some files that we have set up here, and we'll start running that. So this is the main control file for Docker, and we'll use Docker Compose, which is a utility built on top of Docker to make things even simpler. So we can just have this configuration file, which will do basically everything we want for us. So I'm in this demo folder, terminal is opened here too. So if I now run Docker Compose up, everything, well, let's hope everything will work as intended. So in the background, things will start running. In this file, we define 3 services. So the FTP service is the server side of things. The FTP client is the web client, and the MongoDB is the storage solution for the access control and some other housekeeping things. So these 3 will interact, and a lot of things will happen automatically out of the box. You can tweak this in all things you want. Out of the box, this is the standard setup. So we'll run this. Takes on my machine about 30 or 40 seconds. And then we see here application started. So given that everything is up and running as it should, we'll go to localhost. As we saw here, it's running on port 80. So we can just go to localhost, press enter. And now we are presented with the, oops, it's probably a caching issue, I hope. There we go, that's weird. There you go, it's always happening if you want to demo something, everything breaks. That's not good. Let's see, how can I easily fix this? We might go to a different browser because it's probably a caching issue. There we go. We'll go to localhost. Oops. Uh-oh. This is not good. Let's see, what could go wrong here? I wish now that my video actually worked. I tried to record a video, but of course that didn't work.
Don't worry, it always happens during demo.
Yeah, I tried it at least 5 times this morning and it worked as it should, but...
Yeah, but you see, then you weren't presenting. You didn't know you were in public, eh?
That's true, that's true. Okay, we'll, in the background, start it again, see what's happening. If that fails, then we go to some other options, maybe try on a different port. And go from there. Okay, this at least gives you an idea of what happens if something goes wrong, what you need to debug. Always try a different browser if something is going wrong. Okay, let's see. It's booting there.
For all in attendance, just remember to type in your questions in the chat box if you do have any questions for case and the installation process.
Okay, this is really weird. Luis, as a backup, can you show your local installation? Because I'm not sure what goes wrong here. This is a horrible demo.
But mine is a little bit more complex because I have all the stores and so on.
That's good enough for now. I'll,
okay.
Don't get.
Let me shut down my installation. Down. Okay. Let me share my screen now. Okay, I'm going to share all my, let's see. And I'm going to bring some screens to a new workspace. Second. So bring this. Can you see my screen?
Yes, we can.
Yeah. So this is my Docker Compose. So we have the Fedora point, the server side, the client. Here, because in my machine I have a web server running on the port 80. I wanted the Fedora point to run on port 8000. So that's the external port for the Docker. And
so just to interrupt you a bit, you may need to widen your terminal screen so we can see a bit clearer.
Let me zoom in. It's because the screen is really large.
Yeah.
Okay, now here, I have the zoom here. Is it better now?
Yes.
Okay. So here is the internal port of the Docker image that uses, but this is the port that I want the Docker image to expose to my environment because I didn't want the default. If you don't put that, as case didn't have that, it's going to be on port 80. Then here I already set up my triple store. This is also on the documentation, how I do that. I'm using GraphDB, and that's the port that is the default port of GraphDB. I left that as well. This is no longer needed. We used to have a different application as the editor. Now it's embedded in the client, and this is the MongoDB. And then here I have some path where this the data here for the GraphDB is the actual metadata, and for the MongoDB is the the access control, the housekeeping part. So this is my configuration file, and then here let me just zoom in as well. This is compose.
Yeah, I'm almost up and running again. There was some conflicting port running rogue. Weren't probably killed from another process. So
is yours working again?
I'm almost up and running. Let me give me a sec. So
okay.
You can whatever you were explaining for continue for 60 seconds and then I'm done.
Yeah, yeah. No, I'm just putting up. So here you can see, for instance, in my Docker dashboard. Let me go back to my here. So this I don't think that I can increase the size. No, that's just the size. So here I have it's a dashboard for the Docker environment where I have all the Docker images running. So I have this bundle that I created defined here. So the FTP, and then this is composed with of these 4 images. So the Federa Point server itself, this one, the client. So these are from our implementation, and then the MongoDB and the GraphDB. So I chose to use a GraphDB also on Docker, but I could install natively in my machine a triple store and just point to that. And then here I can grab back my the browser, and then you can see here that I'm using port 8000, and that's my Federa point, and still it's booting up again. The GraphDB takes some time to load back, and then the Federa point needs to. Oh, now I have the same problem as Case. Damn it!
Oh, this is a typical demonstration.
The only thing that I did was to shut down the Docker and turn up again.
Yeah, I know there are some caching issues, some persistent caching issues somewhere.
Yeah.
I'll
back up.
Yep, I think so.
Okay, I will unshare my screen and you take over again.
Wait. Wait a minute. Let's see. Oh, I'm hit by the cache bug hard, real hard. It's not doing what it should because caching issues remain.
I see a question from Frederick in the chat box asking, with this training, what happens if you are not an IT guy? I believe to execute some of the things that Case and Luiz are doing would require some computer knowledge.
Yeah, for sure.
From the server side of installation of server applications at the very least. So when you have your data point, there will have to be someone who's knowledgeable in that space, ideally.
Yeah, no, definitely. The session for today is targeted for technical people that are able to install things in a server and things like that.
Yes, so mainly the individuals who will do the technical deployment as well as the maintenance over time.
And then there will be someone else that will, for instance, there is one role, is a kind of system administrator. That's the person that's going to deploy the Fedora point and maintain the installation. Yes. And then we have another role, which is let's say the Fedora steward, that's going to feed the metadata and manage the metadata and so on. This is a different role.
Yes, and for the data stewards, I believe that role is mainly being covered in the metadata for machines workshops that Eric is running every Tuesday for the next, I think, 7 to 8 weeks.
Yep.
All right. So I'm up, but apparently there are some caching, some persistent caching issues somewhere. So let's see how far we get, and otherwise we'll just go into try to take a different approach. Anyway, so running the default setup as we saw in the documentation should get you a bare bones fair data point up and running. This has some default metadata configured. So this is of course just bogus text to get something, but there are a number of properties that are generated automatically. It assumes English by default. It has a default license. All these can be configured in the properties files or updated through the editor that's built in. So by default, this works. You have 2 roles defined, also in the documentation described. We have the admin account, it's called Albert Einstein, and we have a user account by the name of Nikola Tesla. And the admin can basically, well, edit, delete, and create everything. So here we create an example catalog with some version number, some license. You can see that a small blob of RDF will be posted when this is saved. Saving that will just give you another catalog. See, I have the admin role currently because I'm logged in as Albert Einstein. So that gives me all rights for this catalog. I can edit it, I can change some settings on who does what. I can make other users owner, or I can make them data provider. And I can edit stuff. What was in the catalog? Edit stuff for the properties that were automatically added. You can change that, or I can create new data sets, stuff like that. So that's the bare bone situation. And from there, you can do different things. So my instance now is running on port 80. If you already have something running on port 80 or you want to run it on something else, then you can configure the system to run on a different port. You need to set the configuration file, because then the server knows where to look for the configuration and go from there.
To stop you a bit, so for the 404 error, we do have a question. How exactly did you fix it? And if any of our techies do encounter it, what exactly should they look for as the causing agent?
That's a very good question. It's a caching bug somewhere. So usually emptying the cache will fix it. But that said, Luis just got hit by it. I just got hit by it. There's something wonky going on. So we're working on a page in the documentation to, at least we only see this in the, have only seen this in the local deployments, working on a page to have a list of steps that you can go through. So that's in the works. So far, cleaning your cache should work, but sometimes, as I just had, sometimes it doesn't. But for sure, it's a very good question, and we hope to have a typical solutions document up soon.
All right. We still have another one. I don't know whether, I think it's Luiz. There's a question on the triple store. What is it, the exact role does it play? Why is it necessary? Is it to connect metadata to the case report form?
No, the triple store, because the metadata that we have is represented in RDF. So we could, of course, we could produce the RDF representation of the metadata content and store in a file, but we store that in a triple store. It's just because this is the default way of storing graph data. And the metadata in the Fedora point is graph data.
All right, I hope that does answer the question. Great, he says he understands. Kees, do continue.
So now we'll see if the cache bug will hit us again hard. We'll try to replicate the situation that Luiz has on his machine. So we have running on a non-standard port, so port 8000. Let's see if that works here. So we'll take this one down. We'll say docker compose down to make sure that the servers are taken offline. Then, and of course, these also have the in-memory triple store, and the Mongo stuff is also stored within the Docker container. So it takes a while to dump that data too. If you have the data persisted, then some things are a bit faster. For now, we'll just use this example. So if all goes well, things should be up with running on a different port, namely port 8000. So while that's loading, we can look here, and in the documentation, there's an explanation on how to make sure that this data is stored. Now, of course, if you run on a server environment, you want to make sure that you mount this data somewhere where it's on whatever safe network copied RAID 10 system, where everything is backed up twice or thrice. But that's that's something that's outside of the scope of this documentation. That's something that the IT person, the sysadmin, has to make sure it's happening properly. Let's see if this is up and running. Okay, so now we should be able to go here, say we go to 8000, and let's see if the cache bug hits us again. There we go. Okay, so same thing, running on different port. The need for these different ports in the configuration is because the server and the client run on different ports internally within the Docker setup. So the server needs to know what the user-facing URL is so that it can reflect that in the metadata. So in this case, we configure that through this thing. Now, of course, as Luiz mentioned, the FAIR principles state that it should be assigned, metadata should be assigned a globally unique and persistent identifier. So for that, you want to have a persistent URL. We'll go into a quick sidestep here and take a look at what that looks like. So this is an example Perl. Perl.org is a system that lets you create persistent identifiers. It redirects you to it redirects the URL that you configure to whatever is behind it. But we can make whatever we want for that. So if we could say I want to run everything for example.com, then that should be fine. If there are any questions in the meantime, we'll just restart this and see if the metadata has the actual persistent identifier. We can take questions in the meantime.
Do we have any questions for Kees directly? For those unable to type in the chat box. All right, I think we are good. Guys are really following.
Good. So then while this is loading in the background, we can take a look at what we can do to store the data, the metadata at least, in a persistent way. By default, as stated, it was running in an in-memory store, just to have the basic setup for a local deployment as easy as we can. But of course, if you run this in a server environment, you want things to be a bit more persistent because, well, you never know when your service breaks. So to do that, we can define different stores and link that in the configuration. We'll go into that after this is loaded. So we'll go here. We're still running on port 8000, so that should be fine. And then from here, okay. So this is all the same because the only thing we changed was the persistent identifier. So if we now go to, let's say we take our favorite command line utility and we go to curl on localhost 8000, and we'll say we'll want the metadata in turtle format. Then we now see that the persistent identifier, as we defined it within our configuration file, namely example.com, is now the main identifier for our metadata. So here we see some of the fields in the user interface, like the access right, the description, version, the language, the license, all connected to that main, between quotes, persistent identifier that we configured. So for local deployment, this is not really needed. For a production, between quotes, environment, you probably want to have a nice persistent identifier. So that's that. Then moving back to the storage. So Luis had I think a GraphDB repository installed. We'll just see what happens if we install our own Blaze Graph, which is just another one of the popular triple stores available. We'll copy that configuration in here, and we will copy the section on Docker Compose in here. We'll tweak it just a little bit because we don't necessarily need this port mapping right now, because everything will be handled internally. And now we see that we map this local path to the container specific path. So whenever we run this thing again, so we take it down for now, wait until everything is taken offline. We'll things up again. Now things should be configured to run with the Blaze Graph triple store instead of the standard in-memory triple store, which also means that if you want to, you could start using the metadata that is stored and do queries on it or expose it through some other means. If you set it up correctly, then you can expose it to the outside world, make sure that the credentials are properly configured, that nobody can just either clean your database or do other things with it, and maybe have some proper timeouts on it. But given that that you did all these things, you could choose to expose your triple store too, which in itself can also be described in your fair data point metadata, that you have your metadata available in a Sparkle endpoint. So let's see, that's running in the background.
We do have some questions in the chat box.
Go ahead.
One was on the video or documentation on installation of the fair data point. I believe you did say you are working on a video tutorial, more or less.
So I was trying to do that, but I had some audio issues that that prohibited that from being usable by anyone else than me, because I know what I was talking about. But yeah, for sure that will be made public hopefully soon. so we'll communicate that through the whatever channels are necessary. Okay, right, so running the same thing. Of course, here everything should still work, assuming that the cache bug won't hit us. But now everything is stored within this BlazeGraph service. And this is, in this case, at least specifically for BlazeGraph, this is the data that is persisted now. So if we take this, the entire service down and boot it up again, given that this information is still there and the mapping is still in place, you boot it up with the same metadata as you had before. We're not limited to BlazeGraph. We have some different stores supported out of the box. Let's see where that is. So, of course, the in-memory stores is set up by default. There's the RDF4J native store, which is a little bit more performant and can also be stored to disk, although this can also store to disk if you really want to. And then we support AllegroGraph, GraphDB, and BlazeGraph, which are the easiest things to work with in triple store land. Of course, other things we'll work to might require a bit more configuration, but that should all work. So you saw GraphDB for Luiz's deployment, BlazeGraph for my deployment. In our demo deployments, I believe we're also using GraphDB, but I'm not 100% sure about that. So all the setup required for that is explained here. There is one thing I don't fully recall if Luiz mentioned that. We have a automatic call home feature enabled since the version we released yesterday, where a central registry is pinged if their new fair data point comes online, so that that information is accessible by others through a central means. If you don't want that, if you have either sensitive data or you have other reasons not to announce that you have a fair data point, there's this configuration setting you can put in your properties file that will disable that that call home feature. I assume because this is the FODAN consortium that people will want to have their data public, but if for whatever reason you don't, you can disable it through this this thing. And then, so there is a default setup that we use as let's say a reference production deployment, which is using Nginx as a web server to route some things, handle some of the SSL certificates that we have on the, for example, on the demo deployments, and that's all explained here. That's a bit too much and a bit too in depth, I guess, to go through now, but these examples are almost literally, apart from some small implementation details for the environment we deploy on, are pretty much what we use to deploy it. So if you have a server environment, you can base your deployment on this setup. Works well for us. There are default passwords. So as mentioned here, there are default passwords for the two user accounts that are set up by default, the Albert Einstein and Nikola Tesla. So do change the passwords before you go live.
Immediately.
Yeah, preferably immediately, yeah. All right, I think that was mostly it for what I wanted to say. Yeah,
all right.
so.
I'm not sure whether we have any other questions. I can see Luiz has been addressing some in the chat box when it comes to cross-platform installations as well as server requirements. Do we have any other questions? Or are we still processing and trying to take it all in? Questions going once, going twice. I guess that's it. Luiz, okay, if you do have, is there anything else that you wanted to cover before we wrap up? Any closing remarks?
I just thank you for the opportunity, and I copied all the questions and the chat to a document to make sure that all of these are addressed in the video.
Yes.
To be as complete as possible.
Yeah, so Luiz and Case will be doing a video on the same for installation and any other questions that we had during the session, just to make sure everything is comprehensive when it comes to FDP deployment. So thank you, everyone. We really do appreciate that you took the time to be here. Just some announcements before we sign off. The recorded version of this webinar will be available on the Vodan website next week. So if you did miss part of it, or I'm pretty sure we would all like to review the topic again, just be sure to check out the Vodan website to access the recording. Also, we will be having the second installment of the Metadata for Machines workshop on Tuesday next week, facilitated by Eric. Details on how to register for it, as well as what is going to be covered next week, will follow. So be on the lookout for the communication on the various Vodan Africa communication channels. And by the channels, we mean email. Be on the lookout for an email from Ivy, as well as check out on the Slack platform. We have some channels set up there, as well as the different WhatsApp groups. I see a question on where can I send other questions that we may have later. Just put them up on the Slack platform. I believe we will add Luiz and Case to that platform as well, so that they can be able to address some of those questions going forward. All right. So thanks again for joining us, and we will see you guys next time. How do I find Slack? I believe Ivy will send the link on how to sign up to the mailing list. So please be sure to sign up. The link is go-fair.slack.com. For all of those asking for the Slack channel, we will post the link in the chat box as guys sign off. So just be sure to stay back if you do want to receive the link. Otherwise, I believe we have come to the end and we are all free to leave. Thanks again.
Thank you.
Okay, thanks. Bye-bye.
Bye.
Thank you. Thanks.
Okay, bye-bye. It was a nice presentation. Thanks.
Yeah, thank you, Ghosty. Bye.
Thank you. Hope to look forward to for the technical knowledge more on that, especially.
Susan, thanks for performance today. Thanks so much.
Thank you.
Bye. See you guys later.
Okay.
Thanks so much. Stay safe and also stay home.